My name is Mohsin Raza, and this video is a part of Recon project. In this video, I will talk about simulation and reconfigurable manufacturing system design. For years, simulation has been used as an important tool for the design and analysis of manufacturing system. Using simulation, we can create virtual models of manufacturing systems, perform analysis on those models, and can get very important results about the current and future performance of the manufacturing system. Manufacturing system simulation is a proven, powerful tool for designing and evaluation of a manufacturing system, as it is a low cost, low risk tool that enable us to perform quick analysis and get meaningful insights about the performance of the manufacturing system. Shifting from a dedicated or flexible manufacturing system to a reconfigurable manufacturing system required significant amount of time, money and effort. Therefore, it is very important in the beginning to evaluate that the potential reconfigurable solution will be able to meet organizational objectives. Simulation, more specifically discrete event simulation, offers us this opportunity to evaluate several reconfigurable alternative solutions beforehand and to see that whether those solutions are able to meet organizational objective or not. Also, simulation can help to perform reconfigurability analysis and help to determine the minimum number of machines that are required to fulfill the demand. In the 4-step Recon method, simulation is one of the important tools that we can use throughout. For example, in the first step, a less complex and a quick and dirty simulation model can be used as a communication tool to showcase the reconfigurability potential of a particular system. In the second step, simulation can be used to perform detailed analysis of the manufacturing system and to develop alternative reconfigurability options. And finally, a detailed simulation model of the potential reconfigurable solution can be built and tested before starting the actual implementation. Several simulation software are available in the market to model and simulate manufacturing system processes. Some of them are Technomatics Plant Simulation, Anylogic, Arena, Simu and Flexsim, and there are so many others. In Recon project, we worked with several industries both in Denmark and Sweden to test out several Recon tools including simulation. From now onward, I will try to discuss 2 company cases that will help us to understand that how simulation can be used in the design and analysis of a reconfigurable manufacturing system. Case 1 is about a Danish manufacturing company which is facing the challenge of huge product variety and longer lead times. The company is looking for a more reconfigurable solution that may increase its ability to deal with huge product variety, reduce lead times and increase the system throughput. After the detailed investigation and analysis of the current production system, it was mutually decided that company need to shift to a new reconfigurable manufacturing system that may include the modular machine and help the company to deal with these challenges. Through simulation, a comparative analysis of the current and future production setup was performed. Here in the figure, you can see the simulation model of the current production setup. In the current production setup, you can see that there are 4 feeding stations which are feeding 4 different types of variants to the assembly station through a conveyor system. The assembly station will glue all the 4 variants together and send them through the final process through another conveyor system. The throughput of the current production system is 2000 units per day. The simulation model of the proposed production system is like this. There are 2 feeding stations and each feeding station is capable of feeding 4 different types of variants at the same time through a conveyor system to any one of the 4 available gluing stations. And finally, in the end, we have 2 workstations for the final process. The throughput of the proposed production system is 8000 units per day. This new proposed solution will reduce lead time substantially as we can simultaneously process batches with longer lead time and shorter lead time. The proposed production system will reduce lead time substantially as we can process batches with shorter and longer lead time simultaneously. The proposed production system is covering less physical space, and there is a further scalability option for future if required. In this case, the simulation has given us a very clear understanding of the proposed production setup in comparison to the current production setup. Case 2 is about a company from Sweden. A simulation study was conducted to explore the scalability options for the case company and to increase the system throughput. The detailed simulation model of the current production system was built and analyzed. As you can see from the resource statistics graph, the packaging process in the current production setup is the bottleneck, and also process F is limiting the throughput of the system. It was observed that by adding 2 more packaging machines and 1 F workstation into the current production system, 25% increase in the total throughput can be achieved in a year. Similarly, through simulation model experimentations, several other options were explored. For example, increasing the number of shifts at particular workstation, also decreasing the number of shifts on certain other workstations, and to see that how it is going to impact the throughput of the system. In conclusion, simulation is an important tool in the design of reconfigurable manufacturing system. It does not only help us to test and validate potential reconfigurable solution, but also help us to generate different alternative reconfigurable solutions. Simulation is also an important communication tool that may help us to visualize the future manufacturing system with different reconfiguration options. Simulation is also an important communication tool that may help us to visualize the future manufacturing system with different reconfigurations. Thank you for watching this video. Recon project is funded by the Danish Industry Foundation, and the project partners are Aalborg University, the Danish Technological Institute, University of Southern Denmark, and Jönköping University, Sweden. You can find more information about Recon project on our website. Thank you.